A binary operation on a set T is a function that maps the Cartesian product of T to an element in T. So we have for all x and y in our set T, x star y is also an element of T. Now we say our binary operation is commutative if for all our ordered pairs x, y in the Cartesian product of set T, we have the binary operation x star y being equal to y star x. And our binary operation is also associative if for all elements x, y, and z in our set T, we have x star y star z being the same as x star y, and then performing our operation with z. Now an example of a binary operation is real multiplication. Because we take two elements from the real numbers and map that to another real number. And another example is if we had a binary operation on a set of binary numbers and we define our binary operation on x and y being equal to the minimum of the numbers x and y chosen from that set. So if we represent this using a function table, we have our ordered pair x, y and our binary operation. So our possibilities of ordered pairs from this set is 0, 0, 0, 1, 1, 0, and 1, 1. So in this case, our binary operation, being the minimum of the two values, gives 0, 0, 0, and 1. And we can also represent this using a binary operation table. So we have our binary operation and our values from our set. So the minimum of 0 and 0 is 0, and so on. The minimum of 0 and 1 is 0, and the minimum of 1 and 1 is 1. And you may interpret this as the AND operation on two binary numbers.